fractions. Okay, so put the title on your paper as fractions. Okay, now we can add and subtract fractions, and we can multiply and divide fractions. And remember the rules, just like when we do integers, okay, the rules for multiplying and dividing integers were the same, and then the rules for adding and subtracting integers were the same. And it's the same thing with fractions. You have some rules for adding and subtracting fractions that are the same. And then you have a different set of rules for multiplying and dividing fractions. So our first example would be 5/3 plus 4/7. Write it down. Now, to add and subtract fractions, what must we have? Zoe, a common denominator. So that's my clue up here. Common denominator. So write it on your paper. Okay, you must have a common denominator when you are adding and subtracting fractions. Okay, do you have to have a common denominator for multiplying and dividing?
No.
No, you don't. But for adding and subtracting, you must have a common denominator. Now, what's really important is the way that you write your steps. Okay? So I don't want things just crossed off, and I definitely do not want you writing things out to the right side of your paper. Okay? We always write down in math. So you are going to take your equal sign and put it here. Now, what is the denominator that I want to have for 3 and 7? Malia? You could do 21. So I'm going to choose 21, and I'm going to write it on my next line. And notice I set up my fraction. Okay? And I'm saying, all right, I'm turning these things into 21. So how did I go from this 3 to this 21? What did I do, Nick? I multiplied by 7. And if I do something to the denominator, I have to do it to the numerator. So 5 times 7 makes 35. And now, how did I go? Raise your hand. From 7 to 21. Sabrina? I multiplied by 3. So if I do it to the denominator, I have to do it to the numerator. So 4 times 3 makes 12. And notice I'm moving in a downward direction down my paper. Okay? Now my denominators are the same. What do? What do you think, Ramon? You add them. Are you adding the denominators? No, you're only adding the numerator. So I'm going to keep my denominator the same, and I'm going to add my numerators. And over here I can do my math. 35 plus 12, and I have to tell you this is where lots of you make your mistakes. It's on the easy part of the problem. And you're not adding correctly, so make sure you're adding a little bit more slowly to get the correct number. 5 plus 2 is 7. 3 plus 1 is 4. So this makes 47 21s. Okay, 21st. Now, is it simplified?
No.
Okay, why do you say that, Michael?
Yes, it is.
Why do you say that, Michael?
Because 41 is a prime number.
41 is a prime number, except we're not dealing with 41. We're dealing with 47.
47 is a prime number.
47 is a prime number. So there's nothing else that can go into 47 except 1 and 47. So this fraction is in simplest form. I want it left like this. I do not want a mixed number. You can't check it. That's right. You can't plug a mixed number back into a problem and check it. Okay? So I want improper fractions in lowest terms. So make sure that all your answers are in lowest terms, because otherwise, guess what? You lose a point. Okay? So it must be in lowest terms. Now, let's remind ourselves of how we multiply and divide. Do we have to have common denominators? No, we do not. So if I have 5/3 and I'm multiplying it by 4/7, I don't have to have a common denominator. I just get to do what? Who can tell me? Dakota.
Multiply each number.
Multiply each number. So 3 times 5 times 4 times 7?
Okay.
And multiply the numerator by the numerator and the denominator by the denominator.
Excellent. So we can say that we're multiplying straight across. Numerator times numerator, denominator times denominator. So 5 times 4 is 20. And 3 times 7 is 21. Is this in lowest terms?
Yes.
Connor, why?
Because there is no common number between them except for 1.
Excellent. There's no common number to pull out. Okay, let's try a new page. And this time I'm going to subtract. That's a minus. Okay, I have 8/4 minus 1/2. What do I do? What do you think, Sabrina?
Find a common denominator.
Okay, what denominator would you like to use?
4.
You want to use 4. So this one's going to stay the same. And this one's going to change to a 4. So how do I go from this 2 to this 4? Tyler. Two times what made 4? 2 times 2. So 1 times 2 makes, Tyler, 2. And now my denominator is the same. It's a 4. So I know I have a 4 on the bottom. And 8 minus 2 is 6. Okay, is this lowest terms? No. Now, lots of you do this. Divided by 2 over 2. Guess what? I don't want to see that. I want you using primes. So this is how I want to see it. Okay, I either want you to take it and cross it off and say 6 is really 2 times 3, and 4 is really 2 times 2. Okay, or down here, I want you to change 6/4 to be 2 times 3 over 2 times 2. And if you need to do your prime factor tree to get there, you totally can. Okay, it's allowed. But I want to either see this step or this step. I want to see the prime step. Now, once you have your primes, you can find your equivalent forms of 1. Who can tell me an equivalent form of 1? Dakota.
2 and the 2.
The 2 and the 2. 2 divided by 2 makes a 1. And what am I left with? What's in my numerator? Owen, what's in my numerator?
The numerator is 2.
No, it's not.
Yeah, it's the 3.
It's a 3. And what's in my denominator?
The 2.
A 2. And is this in lowest terms?
Yes.
Yes. Okay, Zoe. Question. Oh, Maddie, question.
You know how you would write divide? Could we go that way?
No.
Or do we have to go down?
No. Down your paper.
Okay.
Down, down, down. The only reason you can come over to the side is to show your factor tree if you want. Okay, Owen, we had a deal. No doodling in math. Thank you. Okay, let's do another one. I'm going to do a division problem. 3/7 divided by, oh, you know what? Hang on, I want to go back to this problem because I want to do it a different way. So let me just erase some space for a minute. And then I want to do this problem in a different way to show you that there is another way to do it. Okay? My problem is here. Rewrite it. We changed it to a 4 because Sabrina wanted it to be a 4. What else could it be?
2.
Aaron?
It could be 4.
What could the denominator be besides a 4? It could be a 2. So if I wanted it to be a 2, I would leave this piece of the problem. This one stays the same. And then I'm changing this denominator to a 2. And what did I do to go from 4 to 2? Nick? I divided by 2, or I multiplied by, what do you multiply by? A half. Okay, so 4 divided by 2 is 2. So 8 divided by 2 is 4. And now you have a denominator of a 2. And 4 minus 1 is 3. And here's my final answer. Okay?
Which was the easiest?
Whichever way your brain works. Everyone's brain works differently. So this way took it to its smallest terms right away, right?
So
you can do it either way as long as you show your steps. Okay? All right, here's back to our division problem. We have 3/7 divided by 2/3. Okay? Do we divide fractions? No, what do we do, Michael?
You multiply the opposites.
You multiply by the reciprocal. The opposite of 2/3 is what? Negative 2/3.
What? No.
The opposite of 2/3.
I thought it was reciprocal.
It is reciprocal, but reciprocal and opposite is not the same meaning.
Don't you just multiply the numerator by the denominator?
No. We don't cross multiply. Cross multiplication is not an option in this situation. So hang on.
No.
I'm correcting some words. Listen carefully. Put your ears on. Okay, we do not multiply by the opposite, because the opposite of 2/3 is negative 2/3. Remember, when we're doing x plus 4 equals 7, what are we adding? The opposite. And the opposite is a negative 4. Right? So, negative is not an opposite. Negative is the opposite. In this case, we take our 3/7 and we multiply it by the reciprocal. And reciprocal means flip your numerator and your denominator. Okay? So we're going to call it reciprocals, because that word is going to be on the STAR test. That word is forever a word in math that you have to understand. It's not the opposite. It's a reciprocal. And now that we have a multiplication sign, what do we do, Megan? Great. And so 3 times 3 is 9, and 7 times 2 is 14. And this becomes our final answer. Okay? One more. Last one. I have 3 divided by 9, or 3/9, divided by 1/3. Write it down. Now, do I divide in fractions? No, I do what?
Multiply.
By the
Reciprocal.
reciprocal. So I'm going to write it. And you must show me the written reciprocal step. You must show me the multiply by 3/1 step. Okay, now, in this case, I don't want to just, in all cases, I don't want to just multiply my numerator times my numerator. I want to take out my equivalent forms of 1 first. Because if I take them out now, I don't have to do it later. Okay, so watch what happens if I just multiply. 3 times 3 is 9. And 9 times 1 is 9. And then what do I have to do? I have to take out my equivalent forms of 1, which is 9 divided by 9. And so I get a 1. Okay, what I want to see is 3/9 divided by 1/3 is really 3/9 times 3/1. And now I want to see that you take it to its primes. 9 is 3 times 3. And this makes an equivalent form of 1. And this makes an equivalent form of 1. So what do I have left in my numerator? There is something.
There's a 1.
There's a 1. And in my denominator, there's a 1. And 1/1 is 1. And I really want to see you using your primes. That's part of this lesson. Part of the lesson is being able to solve for x. Part of the lesson is using your primes.
Is
Maddie.
that the way that we're supposed to do? Or
Yes.
We do, so we're not supposed to do
You
that?
can do it this way because this gave me your primes. But if this number wasn't so easy, like let's say it was
97.
Let's do 27/9 divided by 36/45. Okay, and now we've got really big numbers. So we end up with 27/9 times 45/36. You're not allowed to use a calculator. Lots of you are making mistakes on the silly stuff like the multiplication and the adding and subtracting. So guess what? There's a way to make sure you don't make a mistake. It's called using your primes. What is 27?
3 times 9.
3 times 9, or 3 times 3 times 3, if you take it to its true primes, right? What's 9?
3 times 3.
3 times 3. What's 45?
5 times 9.
Monica? 3 times 3 times 5. Okay, or 9 times 5. What's 36? 36 is 3 times 12, and 12 is really 4 and 3, so that's 2, 2, and 3. And remember, if you can't do it in your head, break it down over here and do your prime charts. Okay? Now, find your equivalent forms of 1. There's 1, there's 1, there's 1, here's another 1. What am I left with in my numerator? 15. What am I left with in my denominator? 4. And guess what? I did no multiplication to get errors. I did no long division to get errors. All I did was use my primes and find my equivalent forms of 1.
Why can't we cross multiply?
Cross multiplication is a rule when there's an equal sign. When it's a fraction equals a fraction. That's when cross multiplication works.
But you're doing the same thing.
You're not, because cross products or cross multiplication is a proven way to do equivalent fractions. You don't have equivalent fractions here. There's no equal sign. So although it looks like you are doing cross multiplication, you're really not, because cross multiplication is for equivalent fractions. And if there's any other variables, if there's any addition or subtraction or a variable in here, your method will not work. It just won't. Cross products or cross multiplication is for equivalent fractions. It's for an equal sign.